One of the most exciting things about Bitcoin is that it makes money programmable. You could program a website to automatically unlock content when Bitcoins arrive, or maybe activate something in the real world, like turning on the lights at an outdoor tennis court for a few hours. Or maybe go the other direction and send out Bitcoins when enough people sign a petition. And you can do all this without signing up with a bank or PayPal. Just write code that talks to other Bitcoin nodes using the Bitcoin protocol. This demo will demonstrate how to do the very basics. Create a Bitcoin address and send a transaction using JavaScript and the Bitcore library. I'm going to skip the installation of Node.js and Bitcore, but you can watch that in the larger course at bit.ly/Bitcoin course. I'll be installing Bitcore, a JavaScript-based open source package of tools made by BitPay. I'm using it because JavaScript is a fairly well-known language, and also because it utilizes the core C++ Bitcoin code underneath, so there's less risk of differences between Bitcore results and the main Bitcoin code. We're going to create a Bitcoin address. Type node to enter the interactive shell. We load in the Bitcore library first with the require function. Now let's create a random 32-byte number. That returns a string of bytes, and we can convert it to a number format with bitcore.crypto.bn. If I type rand number by itself, we see the hex version of this number, and if I type toString, we see the decimal version. Let's make a Bitcoin address from this. First, use the private key command, and then toAddress, and then type address to print it out. You could copy and paste that address into any wallet program and send money to that right now, but don't do that. If you close the terminal window and lost the private key, any funds sent to that address would be gone forever. From now on, I'll use what's called the testnet, a fully operational Bitcoin network to test code on where you won't risk losing any real money. I do this by specifying testnet in the toAddress function. You can see the address looks different now, and real wallets won't let you send funds to it. Compare the process of generating a Bitcoin address to signing up for an email address at Gmail, for instance. On Gmail, I have to check with Google to see if an address I want, like scott@gmail.com, is available. On Bitcoin, I just picked a random number and ran some commands that transform it into an address. I didn't check any central service or even the Bitcoin network to see if that address was already in use. How is this possible? What if I picked an address someone else was already using? Before I elaborate on this, let me explain just what Bitcoin addresses are and how they work. The full course continues on here to talk more about Bitcoin addresses, but I'm going to skip straight to sending a transaction. The first step to playing with Bitcoin is to get your hands on some. We're going to obtain coins on the testnet to avoid losing any real money. If you Google Bitcoin testnet faucet, you can find several websites that will send you a small amount of test coins. I'm going to go to bitcointestnetfaucet.com. Now we need an address to send these coins to, so we're going to make a new address. However, it's important that we don't lose the private key to this address, so we're going to store that key in a file this time. Run node again and require the Bitcore library as before. Then generate a new random private key and add the following function at the end, toWIF. WIF stands for Wallet Import Format and is a format with some error checking and extra information to tell wallets what kind of key it is. Now create an index.js file where we'll both create and send the transaction. I'm first going to copy in that private key string from the console, then convert it to a private key, and then to an address. Save the file and go back to the console. If you're still in the Node shell, exit by typing Ctrl+C twice. Then type node index.js to run the file. In the output, we see the address. Copy that and paste it into the faucet form. You need to get enough to at least cover the fee on sending a transaction. The minimum fees change according to market conditions, but BlockCypher has a page that estimates these for you. At this time, the fee is about 0.0005 bitcoins, so we'll type in 10 times that, or 0.005 bitcoins. Note that some forms are in satoshis, which are the smallest unit of Bitcoin, 1/100 millionth, so you might need to convert these numbers on another faucet. Congratulations, you just got your first testnet Bitcoins. Let's see how to send those now. Go back to the index.js file and add the following lines to generate a second address to receive the coins. Here we're making a new address, but this time from a string instead of a random number. The string gets converted to a 256-bit number through a SHA-256 hash, which I'll talk about more soon. This is a very risky way to generate an address, as humans are bad at generating truly random input, but I wanted to demonstrate it. So now we have a from address and one output address. We need one more piece of information to be able to create a transaction, the input transaction. A given address may have several unspent outputs available if multiple transactions have been created sending money to it. We need to specify which one of those unspent transaction outputs are going to be our inputs. This requires a connection to the Bitcoin network. Go back to your console and now install Bitcore-Explorers. Now go back to our index.js file and add the following text. This function queries a server run by BitPay's Insight server, in this case test-insight.bitpay.com. The real power behind the Bitcore software is running your own full node and querying that instead of a server you don't control. You can do that by typing bitcore-d, but this currently requires over 100 gigabytes and several days of processing to set up. Running a full node means downloading and checking every transaction ever created and continuing to receive and relay all new transactions. It's an intensive task, but remember, this is the price of decentralization and minimizing trust. Every peer on the network maintains its own ledger. So for the sake of a quick demo, we'll just rely on BitPay's server, which the Explorers library defaults to. I'm going to comment out the previous console logs before running the file again with node index.js. In the results, we see our address, amount, and a transaction ID with an index. Remember, transactions can have multiple inputs and outputs, so you need to specify an index along with the transaction. Okay, let's use that unspent output in a transaction now. First, create a transaction and then set the unspent transaction output as the from source. Then set our second address as the to address. And let's send the exact amount that's available in the unspent output, 500,000 satoshis. Now to send this transaction, we need to serialize it and then broadcast it using the Explorers module again. I'm going to leave the broadcast function commented out for now. Now we got an error, something about the fee being too small. This is one part of transactions that I haven't discussed in depth yet. The Bitcore library provides some safety checks on transactions, and checking for an appropriate fee is one of those. Transaction fees are collected by the bookkeepers or miners, and if you don't have a sufficient fee, it's likely your transaction will get ignored. Interestingly, there's no fee field in a transaction. Rather, the fee is just the difference between all the inputs and outputs. To add a fee, we need to reduce the output to include one of the minimum fees we saw on the block cipher site, 50,000. I'm going to change my output down to 10,000 or 0.0001 bitcoins. Remember, all inputs must be spent completely, so we need to include a change address in order to send a small output with this larger input. Let's return the extra back to our original address. Note that best privacy practice is to generate a new address for the change. Now if I print out the transaction using tx.toObject, we can see that 10,000 goes to my destination address and 480,000 is going back to my change address, leaving a fee of 10,000. Bitcore automatically applies a default fee, but I'm going to increase it with the fee command just to be on the safe side. Now when we try to run the code, we get a different error, this time about inputs not being signed. This is where we unlock the funds. We need to use the private key associated with the address in the input transaction. If I print the transaction out again after signing it, we see a script applied to the inputs. I mentioned before that these are more than just digital signatures, but rather a small scripting language. If I print out both the input and outputs with the script to string command, you can see some of the commands in this scripting language. It turns out that the default output is more than a public key, but a function that says something along the lines of provide a signature and public key such that the hash of the public key matches the Bitcoin address, and the signature, transaction, and public key all verify together. I'll explain hashes shortly, but for now just think of them as a compression function. When I first introduced Bitcoin addresses, I noted that the address is not just a public key. It's actually a hash of a public key with some extra conversion to avoid easily mistaken numbers and letters like zeros and O's. This is why the script has some hash commands in there. Another type of much more flexible output puzzle is a pay-to-script hash. To unlock this output, you must supply a script that hashes to the value supplied. This is commonly used to enable outputs that can be unlocked with 2 of 3 private keys. A final output worth mentioning is the data store, implemented with an op-return command. This output can never be spent, but can be used to permanently store a small amount of data in the ledger. If, say, you invented a new product, you could store a hash of a description of that product in the ledger to have timestamp proof of when you invented it. Bitcore provides a function for this, tx.addData. Note that this still costs a fee and is also a dead-end output. Any money sent to this address will be unspendable. With those details explained, we're finally ready to send the transaction using insight.broadcast. If it works, you should see the transaction ID returned. We can now go to a block explorer for the testnet and type in either the address we sent the money to or the transaction ID just returned. Congratulations, you just wrote code that successfully sent a Bitcoin transaction. Now remember, we used a BitPay server to broadcast this transaction. We could have also run a full node ourselves to talk to other Bitcoin peers of our choosing and directly broadcast the transaction. Several sites also provide web forms that accept raw transactions and broadcast them for you. This is useful if you don't have a full node running and are using another library that can't directly broadcast a transaction. To do this, I print out the raw transaction and paste it into the raw transaction form, which here is at test-insight.bitpay.com. This video is an excerpt from a larger 3.5-hour course on Bitcoin and blockchain projects like Ethereum. It's on Pluralsight, which is paywalled, but you can watch 95% of it with their free trial.